we're now going to put together what we've learned about quadratics, in addition to what we did in the last unit with linears, and then we're going to push forward a little bit and look at cubic functions. So with all of these different types, you're just going to go through the process. Okay, what kind of information are they getting? What do I know about this? Listing things out, drawing pictures as needed, defining your variables along the way. All of this is going to come together. You're going to be able to write equations. So the very first thing that we're going to look at is what are called area models. So in this problem here, you need to start by drawing a picture. You have a rectangular pond that's 5 meters by 7 meters, and it's surrounded by a walkway of width x meters. So the entire walkway, its width is x meters. So the first part that you want to do is draw this picture. You have your pond, 5 meters by 7 meters. And make sure you read it carefully. You're surrounding it by a walkway of x. So the whole distance around each part is x. Okay. So there's our information so far, based on what I have for a picture. It says write the length and width of the region as a function of x. So now I need to start defining my variables. I'm going to have length, I'm going to have width, and I'm going to have x. So define each of those out. So they kind of defined x for us. X is the width of the walkway in meters, L is the length of the walkway and the pond in meters, and then W is going to be the width of the walkway and pond in meters. So now after I've defined my variables, now I need to write the functions for these. Write the length and width of the region as a function of x. So I have to write an equation. So therefore length, let's consider this to be my length here. Okay? It's not going to make a difference as to which one I pick as a length and a width. So if that's my length, write the equation for that. So my pond is 7. Length is the length of the walkway and the pond. So the pond was 7 plus the walkway was x here and x here. And then in between here was a 7, which is the length of my pond. So that's plus 2x. Now I have to look at the width. The width is W is the width of the walkway and the pond. So W equals that pond, which is 5, plus, so that's the 5 here. And now I have walkway x and walkway x to give me the entire width. So that's plus 2x. Well, what kind of functions are those? Those are just basic linear functions. Didn't do anything particular about them. Just added up that unknown feature. Second one, I need to write the area of the region as a function of x. Well, area, well, that's pretty easy. Area of a rectangle is length times width. It says it's as a function of x, so therefore it's a of x. I can only have x's. It technically would start like this, length times width, but I know what length is. Length is 7 plus 2x times width, which is 5 plus 2x. Again, I can't use L and W because it says it's a function of x, which means the only variable that's going to be on that right side, my independent variable, is only going to be x. And I put 2w instead of 2x. Sorry about that. So therefore, I can expand this out, combine like terms together. A of x equals 4x squared plus 24x plus 35. Well, what kind of function is this? We've spent an entire unit on it. Quadratic. Started with two linears. It's a multiplication that makes it quadratic. It combines the two together. I'm going to end up with a quadratic. Quadratic gives me a parabola, and I can answer different questions about it. But that's kind of an area model type of problem. I've got one more area model, and then we're going to get into some standard form types of problems. So an in-ground fence is to be built around the backyard. 8,000 feet is used. One side of your yard is enclosed by water. So here's my water. And the fence is not needed. For some reason, your dog must be afraid of water. So you only need a 3-sided fence. Okay, so with this information, we're going to let L, that's an L there, be the length. Write the equation for the area of the backyard as a function of its length. So here's my length. These are my widths. So based on using the one side as my length, the singleton side as my length, we're going to write an equation. Now, it does get a little bit questionable as to which side is length, which side is width, it would be a different equation if we went vice versa with them. But what's important for you to understand, it says A of L. What's the area in terms of length? I can only have length in this problem. That's the only independent variable I can have. Because normally, in this, if I'm going to talk about the area of it, well, the area is length times width. I can't have a W. This is not acceptable because it says A of L. So really quick, I define my variables. L is the length of the yard being fenced in. W is the width of the yard being fenced in. Now, if you take a look at the problem, I said 8,000 feet is used. I haven't done anything with that yet. 8,000 feet of fencing is being used. Take a minute, pause this, and think about how does that fit in? How is that important? So the 8,000 comes in because it's talking about, that's kind of like the perimeter of the fence. That's the length of the fence. So W plus L equals 8,000. So therefore, 2W plus L equals 8,000, or 2W equals 8,000 minus L. Now keep in mind, I have to get rid of W in my equation because this needs to say A of L. It can only have an L on the other side. So I have to substitute something in for W, which means I have to get W by itself. So I have to divide everything by 2. So W equals 8,000 minus L divided by 2, which is the same thing as 4,000 minus a half L, if you want to go through it that way as well. So therefore, I am okay now, and I can substitute in. It's L times this W, which is 4,000 minus a half L. Therefore, A of L equals negative 1/2, distribute the L through, L squared plus 4,000 L. And I have my equation for the area of my backyard in terms of just L. Again, another problem where I dealt with the perimeter. I brought in area. I now have a quadratic. So these are area models for quadratics based off of the linears. So take a moment, please read through this problem. The first thing that should catch your eye is it says it's quadratic. Because it's telling you it's quadratic, you know what type of equation you're going to be working with. You know you're going to be using y equals ax squared plus bx plus c. This is the type of equation we're going to be seeing. So I need to start by defining my variables. Looking at the information that they give you. I'm going to be defining them with D and P. So what's important for you to understand is which is your independent variable, which is your dependent variable. So it says assume the price is a quadratic function of the diameter, meaning diameter is your control. Diameter is our control, which means diameter is that quote-unquote x value. So this is going to be the coordinate point D, comma, P. Important because now we have to find our equation, or write our equation. The other reason I know that is it says here, expressing price in terms of diameter. The in terms of is your control. Diameter is your control, which means that's that quote-unquote x value. So a couple of ways that you have to figure out, okay, which is my x, which is my y. So now I have an equation, y equals ax squared plus bx plus c. I have to find those coefficients. I have to find a, I have to find b, and I have to find c. In order to do that, I have to have a system of 3 equations with 3 unknowns. Okay, because I have a, b, and c to find. I have 3 variables to find, which means I have a system of 3 equations I must set up. And in order to do that, I have to pull out my coordinate points. An 8-inch pizza costs 85 cents, a 10-inch pizza costs $1.15, and a 13-inch pizza costs $1.75. I have my 3 coordinate points. I now substitute in my 8 for my x values, my 85 cents for my y, or 0.85 technically, because it's in dollars. And the same thing. So I'm going to end up with 3 equations to work with. So now that I have my system of 3 equations, I can solve for my 3 unknowns, which is what the whole point of this is finding my A, finding my B, and finding my C. So in your calculator, set up your A matrix, 64, 8, 1, 110, 1, 169, 13, 1. Inverse of that times your answer matrix, which is 0.85, 1.15, 1.75. So take a moment, plug that into your calculator, make sure you can do that. It's spits out the three numbers you need, your A, your B, your C, in that correct order. I now have my equation for this quadratic function. I can now interpret what this problem means. I can figure out approximately what size pizza costs what. Or if I have a specific price, how much was that pizza? What size was that pizza? All of those different things can now be answered because I have this equation. If you can't find the equation, the rest of the problem will be pretty much impossible to do. So make sure you are able to find an equation based on having 3 points in this problem. So now I can go through in part B. I can find this. I want to find out they made a 20-inch pizza. What would the price be? Now 20 is going to go in for, it's your diameter. Put it in for D, and out pops your price. Make sure you write these in sentence form. In C, I'm having a pizza cost $6. Now 6 goes in for your P. This one takes a little bit more work. So I finished up part P, just plug that in, straightforward, got a cost. Part C, I put the $6 in, so now I need to find the diameter. Again, I've got a D squared, I've got a D. How do I solve this? Got to have it set equal to 0. Now, how do I solve this? Quadratic formula or factoring it. Realistically, it's a story problem. So I'm going to be approximating values if need be. So you may wish to go straight to the quadratic formula. It depends upon your process and what you feel most comfortable with. If I go through and do my quadratic formula, I get 2 values. Okay, which of these works? What's my answer? Both of them? None of them? What's the case? Well, I can't have a negative diameter. So the diameter of a $6 pizza would be 25.106 or about 25 inches. So that's the process you have to look at. What makes sense? Yes, I have 2 answers, but no, they don't both make sense. What does the price-intercept equal in this model? Why do you think it's greater than 0? So price-intercept, think about this. X-intercept is when Y is 0. Y-intercept is when X is 0. Price-intercept is when the other one is 0. That's my diameter. So my diameter is going to be 0. So I have to put a 0 in for all of my D's to come up with that P. So my equation so my price-intercept, D's are 0, that's 0, that's 0, it's 0.45. So that means even if I don't make a pizza, it's going to cost me 45 cents. Now, this is the interpret part. Why? Why does that happen? Even if you don't make anything, you have to have ingredients available. You have to have people on staff. You have to rent a building. That's that cost they already have built in. So no matter what, even if they don't make a pizza, they have that cost built into it to give them that extra little needed push. And then the last part is the vertex. Use it and other points then to sketch your graph. Please keep in mind, the vertex in quadratics is always the lowest or highest point. Always, always, always. So I might not ask for the vertex. I may ask, what is the cheapest pizza? And you need to know that means find the vertex. So if I need to find the vertex, the x value of it, is the opposite of b over 2a. This is in generic form, remember. Opposite of b over 2a. So I find that quote-unquote b value, negative 0.03. So it's a positive 0.03 divided by 2 times 0.01. When I come up with that, I get 1.5. Okay? That's the x value of my vertex. Now I plug in that 1.5 in for d into my equation. And out pops 0.4275. What does that mean? A 1.5-inch pizza would cost 43 cents. A 1.5-inch pizza would cost 43 cents. Take note of letter D. Yes, if you make no pizza, it costs more than if you make a 1.5-inch pizza. These are models. These are story problems. We are fitting an equation to data we have. Is it perfect? No. In this case, does this make sense? No. It should not cost you more to make no pizza versus making a 1.5-inch pizza. It is a model. That's why we talk about models. We fit an equation to data we have. It's not going to be perfect. We then take that information. We put it on a graph. Here's my vertex. It is the lowest point. It goes up from there. It goes up from there. Use the points along the way. One of the things you will also have to do with this is define your pieces of information. Tell me this is your lowest point. Describe. the vertex. What does this mean? What you would physically write on here is a 1.5-inch pizza would cost me, I think it was like 43 cents or something like that. Describe, even if we do not make a pizza, there is still a built-in cost of 45 cents or whatever that was. Describe to me intercepts, describe to me vertex, always in these pictures. The other thing, again, make sure you define your axes. Label with your letters, axis, and label. One last problem. Pause it, please. Read through this really quick. I'm not doing this problem for you. I just want you to see something quickly. In this problem, they say it's cubic. What is cubic? Cubic is y equals ax cubed plus bx squared plus cx plus d. Now I have 4 unknowns I have to find. If I have 4 unknowns, I have to have a system of 4 equations, which is part of the reason I have 4 points here. But they tell you it's cubic, which means I have to have 4 points. The other thing I want you to notice about this problem is it gives you years, 1960, 1970, 1980, 1997. My recommendation to you is define your variables. So this is 0. So 60 in 1970, that's 10. 1980 would be 20. And 1997 would be 37. If you use 1960, 1970, 1980, you may get an overflow error, and you won't be able to calculate the problem. Now, because I changed the way I represented those quote-unquote x values, I have to define those variables that way. So I'm going to say x is the number of years since 1960. Now, sometimes they will physically tell you that process so you know to change that defined variable, but please keep that in mind that you may get overflow problems along the way. If they tell you what your x value is, you need to change it accordingly. If they don't, it is your option if you can go through the process. If you go through this and you do this in your calculator, you're going to get a system, again, of 4 equations with 4 unknowns. Your answer to this is going to be y equals 0.002 t cubed minus 0.106 t squared plus 1.826 t plus 12.4. So you can go ahead and check your work, make sure that you can do this, because you are responsible for knowing how to do cubics as well. Cubics follow directly, though, from your quadratics.